Today's problem is all palindromic partitions. So the problem statement is given a string S. Find all possible ways to partition is such that every substring in the partition is a palindrome. So the first example, geeks. So G is a palindrome, E is a palindrome, E is a palindrome, K is a palindrome, S is also a palindrome. So that's one partition where every substring of geeks is a palindrome. So that's one answer. And the second answer will be G. The single character G is a palindrome. E is a palindrome. K is a palindrome. S is a palindrome. And there are no other substrings which will be a palindrome. If we consider GEE, it's not a palindrome. If we consider this substring EEK, it is also not a palindrome. If we consider EKS, it's also not a palindrome. GEEKS, the whole string itself is not a palindrome. So the only possible answer in this particular case is GEKS, GEKS. The next is abcba. In this particular case, all the single characters are a palindrome. A, B, C, B, A. So all the single characters are palindrome. The other possibility, BCB is a palindrome, A is a palindrome, and A is a palindrome. So A, B, C, B, A is another set of palindrome substrings, and the whole string A, B, C, B, A, if we consider A, B, C, B, A is also a palindrome. So the thing to consider here is, like, we need to find all the substring. We need to check for all the substrings that can be partitioned from the given string S, such that each of them will be a palindrome. So if we consider geeks, so the problem is to consider all the possibilities. So in order to consider all the possibilities, we need to do a recursion on this particular string, and same way, like we need to consider each and every possibilities. Like we can consider G, then we can try to consider GE, and we can consider GEE, and check each time whether the substrings are a palindrome or not. So in this particular case, like, we can define a function to start from index 0. So we'll start from index 0 and see. So if we consider the single character G, it's a palindrome, then we can move forward f of 1. Now we can see whether E is a palindrome. Yes, then we can move forward f of 2. We can see this E is a palindrome. Yes, then we can go to f of 3. And similarly to f of 4. And when we try to go for f of 5, we will we have considered all the strings. We have reached the end of the string, and what are all the strings that we have seen here, that is G, and here E, and here G, E, and K, and S. So all those are palindrome, and we can store into a data structure. Now in this, from here we have G and E, so we can just consider both E. Instead of here, we can directly go to f of 3, and consider all the strings from 1 to 3, that is this EE, and we can check whether that is a palindrome, and we can go for f of 4 and f of 5, like that. So it's basically like we are trying all the possibilities. So if we try to code it up, if S is equal to null, or S dot length is equal to 0, we can return a new empty array list. Otherwise, we need to return array list of string which are the all valid palindromes. Equal to new array list. We can have an array list of string. This is the current string. So in this particular case, at first we will be storing all the possible palindrome substring into this current array list, and once we exceeded our index, or we have moved out of the string's length, then whatever the values that are stored with the current, we can just take it and put it inside our result data structure. So this will be an empty array list. Now we need to make use of a regression. We will do the regression of string s starting from index 0, and we will be populating the current list initially, and once the index has moved out of the length of the string, we will store it inside the result, and finally our result will be holding all the possible answers. So private void dot fact helper string s int current index array list of string current array list of string result. So the base case is like if our current index has moved out of or become equal to the length of the string. So if current index is equal to s dot length, that means we have covered all the string. We have moved from the 0th index to s dot length minus 1 index, and that is one possible answer for us. So we will add into our result. And we will just return. Otherwise we need to consider all the possibilities from the current index till the length of the index. So if int end is equal to current index, end is less than s dot length, end plus plus, we will check if from current index to the end if it is a palindrome. So we can make use of a helper function is palindrome, where we will be checking whether from current index to the end the given substring is a palindrome. If yes, we will take the current palindrome string, which is equal to the substring from current index to n plus 1, and we will add it into our current palindrome string, and we will do the from there we will go for the other possible results. So we will just increase the current index s1, now current and result, and there can be also cases where we are not considering the element from the current index. We need to try for other substrings as well. So we need to remove or backtrack, removing the previous stored results. So we will just do this. We will just remove it from the previous current. Now I have written a boolean, private boolean is palindrome in order to check for whether the character is whether the substring is a palindrome or a valid palindrome or not. So while start is less than end, we will check if s dot caret of end or start equal to s dot caret of n, and then we will continue. If it is not, we need to return false. That is, if we have a s from start to end, it is not a palindrome. That is, we can't read it. Like it won't be the same if you read it from the front or if you read it from the back. So we will return false. Otherwise, we will check for the other characters in that particular substring. And finally, if we completely we went through the substring, we will just return true, saying like it's a valid palindrome. So the time complexity here will be, for each and every index we have two possibilities. So there will be a 2 raised to n possibilities, and for each we are checking whether it's a palindrome. So you can also go till n. So the time complexity will be 2 raised to n in the end, and we have extra space to hold the result, and extra stack space. So it can also be 2 raised to n into n. And let's see what is the expected complexity. Yeah, it's the same. So our space is also 2 raised to n into n plus some stack space that will be consumed in this particular recursive stack. So let me compile if there is any kind of a compilation error. So there are issues actually. So we can see our current index. Okay, instead of current index plus 1, we need to go for n plus 1. Okay. So it's accepted. So maybe I can just try for so at first I will consider this G. So then we have the substring EKS, and then we will consider and we will store this G. Okay, then we will consider this E. So this is EKS, and from there we will consider this particular E. So the remaining substring will be EKS, and we will store this E, and we will consider this E. We will check whether that single character E is a substring. It's a substring, so we will add that as well. We will move forward. Now we will consider this K, and that K is also a palindrome, and we will move to S, and that S is also a palindrome. We will move to the next recursion stack, but we have exceeded the index, so we will backtrack. We will backtrack and check for the other possibilities as well. So if here we consider E single character, here then we will go for EE. EE is also a palindrome, so G and EE is a palindrome. Then we will go for K. K is a palindrome. We will go for S. S is also a palindrome. Same way we will just backtrack. We will check this case, whether K, E, E, K is a palindrome, etc., etc., and etc. So in this particular case, these two will be the valid palindromes.